Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 4, Lesson 8, on how to use factoring polynomials to find solutions, or zeros, or whatever other names there are. And in Lesson 2, remember, Lesson 2, I told you the different things that are really important to know, so please watch that video first. And obviously you want to watch pretty much all the other ones, so don't watch this lesson unless you've watched 1 through 7. So, we're using our 4 ways to factor to find zeros. We know what the zeros look like for certain graphs, but you know how many zeros there's going to be depending on what is the leading power. So, we'll see it here. So if you have x with no power on it, which pretty much just means to the first, you have 1, 0. And this is just the standard parent function, and it would just be there. If you have x squared, we already looked, that's a quadratic. This is just an example. It could be like that, and you have two zeros. If you have x cubed, it's going to be something like this, where you have 1, 2, 3 zeros. And basically you're starting to see that whatever the number is how many zeros you're going to get. But this isn't always the case. So remember, we saw that there's ways to get 1 solution, no solution, or 2 solution for quadratics. There can be no solution if it's like this up here, doesn't even touch the x-axis. There can be 2 solutions if it's just how it normally is. And there can be 1 solution if it only touches it once, like right here. And the same goes for other situations. You can have, technically for the x cubed, there's no way to get no solution, but there is a way to get only 1 or 2. So if you had something like this, then you only have 1. And if you have something like this, I don't know how to do this really. There's really 2 there. So it just depends on the way that the graph is, but how you know if certain solutions you get are imaginary, that means it's a place where it doesn't touch the x-axis. So let's look at an example of how we could do this. So let's look at one. How about this? We already used this example in a different video, but let's use this one. Okay. Whenever you have an expression, you set it equal to 0 to find the zeros. Makes sense, because y equals 0. And we can already look, how many x-intercepts are we going to have? Leading coefficient is 3, so 3. But if there happens to be a imaginary thing, then it wouldn't connect there. So we can solve this by grouping. We see that because there's 4 terms. Our other ways are the addition multiplication one. You can't do that because there's 4 terms. And then you can't do the other ones because of that there's 4 terms also. So when there's 4 terms, you can group. So you should already know how to group, but I'm going to just show you how it would be. You can divide by -2, or sorry, what am I doing? X squared, and then you get x plus 6. And then you have -5, x plus 6 again, and then 0 equals 0. Then you have x plus 6. Remember, these have to be the same. Since they are, that's good. And then you have this. You cannot further factor. So then you just set each of these 2 things equal to 0. And then you solve. For this one, you move x to the other side. Or sorry, -6 to the other side. And then you get x is -6. So that's one of our 3 solutions. Alright, where's our other 2? Well, how do we know there's going to be 2 other ones? Because there's a 2 right here. We know when we take this square root of something, we get two answers, so that's how we know. So then we would add 5 in this case. So x squared equals 5. You take the square root, and the square root of 5 is plus and minus 5. Or sorry, the square root of 5 is plus and minus square root of 5. So we have positive square root of 5, and then we have x equals negative square root of 5. So that's our 3 answers, and if we were to graph this, we could see it would touch the x-intercept here, -6. The square root of 5 is about like 2.3 or something, I think. So it would also touch here, and also touch here. So it might look something like this. Okay, so that's how you do that. So it makes sense. We got 3 solutions. So let's look at one other one, because this hopefully should make sense. Sometimes if you can't factor, remember you have to use the quadratic formula. But you can only do that if there's in standard form, and I already talked about what that is before. That's just if there's, I mean quadratic standard form. That's why it's called the quadratic formula. You can only use it if there's a 2, and then a 1, and then no exponent. So let's look at one other example. How about this? X to the 4th power minus 9x squared plus 14 equals 0. So what do we use? Well, we see that there's 3 terms. We can't use grouping because they can't all divide by something. We can't use difference of squares because there's more than 2. It's not a binomial. And same thing, for various reasons, you have to only use the add and multiply one. So since this is already 1 right here, we don't have to multiply anything, and we see what things multiplied equal 14, and they can add to equal -9, 7 and 2, and they both have to be negative. Negative times a negative is a positive, and negative minus a negative is also a negative, so that makes sense. Then we have x squared, remember it has to be squared if this is a 4, minus 7, and then x squared minus 2 equals 0. Don't have to divide by anything because this was already a 1. And that would be our answer if we factored completely, but we still need to solve. So we have x squared equals 7, x squared, minus 7 equals 0, and minus 2 equals 0. And remember, since this is a 4, we'll have 4 solutions. We can see that 2 and 2, that means 4 solutions. And we see that we get x squared equals 7, and then x squared equals 2. We take the square root, and we find out that x equals the positive square root of 2, the negative square root of 2, or the square root of 2 negative, because the negative isn't in the square root, or that would be imaginary. The positive square root of 7 and the negative square root of 7. Not in it once again. So those are our 4 solutions. If we were to graph this, if we were to graph this, the square root of 2 is about like 1, so we see that there's 1 here, and then the square root of 7 is closer to 2, so we have 1, like, this is an exact, so it's probably something like this. And that makes sense. That, well, it's not going to be exactly like that. Since the x to the 4th is positive, it's actually going to be like this. And that makes sense because when I think I already talked about this in I did in lesson 1. If this is positive, if the exponent is even, then the arrows are going to be pointing in the same direction, and that tells you how many x-intercepts we have. So that's it. We'll just do one more that would be a little bit crazy. So let's look at one crazy example just to see what would happen. Delete, erase, stupid thing. Okay, I hate this. This is much worse than the other app I have been using, and if you didn't already hear, I'm not using it anymore because it froze, kind of like this thing's doing now. Okay, just forget it. That's not going to be erased since it doesn't want to do that. Okay, how about we have x to the, or let's just do 3x to the 19th plus 9x to the 5th, and then plus 27x squared. This thing's gonna look super weird, but we would need to, oh, and then let's just do, oh wait, never mind. These all can divide by what? They can all divide by 3x squared. All these can divide by 3, and then all of these exponents can divide by 2. So we have this, this, and this. Then we see that well, how many solutions are we going to have? 19. Ugh. Well, that's just how it is. The 3's cancel, and then 19 minus 2 is 17. So we get this. We get x to 17th, and then plus 3x to cubed, and then not plus 9. Alright, well, we would need to factor further, because we have x to 17th and x to the 3rd, and that's not possible to solve. So let me think, is there even a way to do this? Well, the answer would be not something that you know how to do. But let me just, I can tell you what this graph would look like, at least. It would have 19 x-intercepts. So, I'm going to graph it into my calculator and see what it would look like. It might make it go crazy, though. So, 9x to the 5th plus 27x squared. Okay. Okay, yeah. It's going super crazy. Well, to me, it looks like on there that it only does this. But maybe if I zoom in window. Let's do 2. Yeah, I don't understand it. This must just be an irregular function that I don't know about. X to the 19th. Oh. Well, x to the 19th by itself does this. Like that. And that makes sense, because remember, odd exponent, then it must touch that many times. So maybe it just looked like that, but it's so crazy that it touches such close places together. So that was kind of pointless, but I just wanted to see what that would be like. So thanks for watching, and I'll see you on the next video.